GM has just unveiled a game-changing engine that may render both electric and gasoline-powered cars obsolete. This isn't just an incremental step toward cleaner cars, it's a leap forward. Compressed air technology is poised to reshape the future of transportation, and GM is betting big on it. Until now, GM had been searching for that breakthrough innovation to set them apart. Today, they believe they've found it. Compressed air, once considered weak and impractical, has been reinvented into a powerful and viable technology by GM engineers. No longer just eco-friendly, this engine could revolutionize the entire automotive industry. Unlike traditional gasoline engines that burn fuel for power or electric vehicles or EVs that rely on battery-stored electricity, GM's new compressed air engine uses a pneumatic motor. This motor operates by harnessing air pressure stored in advanced high-tech tanks. While it may sound simple, the technology represents a massive leap in clean, efficient energy for vehicles. But GM didn't stop at merely reviving this technology. They overhauled it. By utilizing high-pressure air tanks and new materials, they've overcome many of the challenges that plagued earlier versions. The result? A vehicle that performs just as well as gasoline-powered cars, but with zero emissions and minimal environmental impact. Perhaps the most exciting feature of this engine is its environmental impact. Compressed air is just that, air. There are no harmful emissions, no toxic byproducts, and no reliance on non-renewable fossil fuels. The engine doesn't require gasoline, diesel, or even batteries, eliminating the need for rare earth materials in its construction. This presents a significant advantage over EVs, which rely heavily on lithium and other rare elements that are both expensive and environmentally harmful to extract. While EVs are a step in the right direction, it's no secret that in many parts of the world they are still powered by coal and other fossil fuels through the electrical grid. This weakens the green argument for EVs, making them less environmentally friendly than they appear at first glance. Compressed air engines bypass this issue entirely, running on pressurized air, no fossil fuels, no fumes, just pure clean energy. This development couldn't have come at a better time, as the global push for greener vehicles and tighter emission standards intensifies. GM's new engine could be the solution to a future without gasoline. One of the major selling points of compressed air engines is their simplicity. Compared to the complex systems found in both EVs and conventional gasoline engines, these new engines are remarkably straightforward. They accomplish nearly the same tasks as a gasoline engine, but with far fewer moving parts. There's no fuel injection system, catalytic converter, or advanced emissions controls, all of which drive up costs in conventional vehicles. As a result, compressed air engines can be produced and maintained at a lower cost. Because they don't burn fuel, compressed air engines also don't generate the extreme heat that gasoline engines do, reducing wear and tear on engine components. This translates to a longer engine lifespan and lower maintenance costs over time. Additionally, since compressed air is both abundant and inexpensive to produce, the operational costs of these engines are expected to be significantly lower than those of gasoline or electric vehicles. This breakthrough could have major long-term implications for the automotive market. If GM's engine performs as well as expected, it could lead to a dramatic reduction in the cost of manufacturing and owning automobiles. This is particularly crucial at a time when the automotive industry is striving to make cars more affordable for a growing global population. It's safe to say that the path to developing compressed air engines has not always been smooth. Past attempts to create compressed air vehicles were plagued by a wide range of issues. Chief among them was the lack of power. Early models simply couldn't produce the kind of torque and acceleration that gasoline engines offered, making them impractical for most drivers. Range was another problem. Compressed air vehicles had limited range and required frequent refueling, which restricted their use for long drives or even daily commutes. Additionally, the process of refueling or recharging the air tanks was often cumbersome. However, GM claims to have overcome most of these challenges by employing high-pressure air tanks and reworking the engine for greater efficiency. They've increased power output to levels comparable to gasoline engines. The use of lightweight materials and structural reinforcements in the vehicle's chassis has also extended the range of compressed air cars, making them viable for everyday use. When it comes to refueling, GM has found ways to make the process faster and more convenient. Unlike the early prototypes that required extended periods to recharge the air tanks, the new system allows for rapid refueling, making the stop almost as convenient as filling up at a gas station. One of the primary concerns with any compressed air system is safety. Driving with tanks of pressurized air raises understandable safety concerns. Early models of compressed air vehicles were criticized for the risks of explosions if the air tanks were damaged in a crash. GM has addressed these concerns by using advanced materials in the design of both the air tanks and the car's chassis. With innovations like fiber-reinforced thermoplastics, GM has made its compressed air vehicles significantly safer than previous models. The vehicles are designed to safely release stored air in the event of an accident, preventing explosions, while the structural integrity of the car is reinforced to protect the occupants in a crash. This focus on safety is crucial as GM prepares to bring this technology to market. Consumers need the confidence that they are not only driving a green vehicle, but also a safe one. GM isn't developing this technology solely for innovation's sake. They are looking ahead to the future of the automotive market and recognize the potential of compressed air engines to help them capture a large share of that market. While GM has achieved success with electric vehicles, or EVs, they know they are trailing behind companies like Tesla. With this new air compression technology, GM sees an opportunity to leap ahead and create an entirely new market. This new engine doesn't just offer a cleaner alternative to gasoline, it introduces a third option in a world largely focused on the competition between electric and internal combustion vehicles. If GM can successfully move into mass production, they could position themselves as leaders in the next revolution of automotive manufacturing. This is the first time a large manufacturer has attempted to harness the power of compressed air on a broad scale. While Peugeot experimented with a hybrid version of this technology in the 2010s, combining compressed air with an internal combustion engine for excellent fuel efficiency, the project was quietly shelved. Many speculate that pressure from oil companies played a role in that decision. GM appears determined to avoid a similar fate. The company has worked in secrecy for several years on this technology and is confident it has solved the issues that derailed previous attempts. With their compressed air engine now ready for launch, GM is positioning itself for a significant market breakthrough, which seems imminent given the growing demand for new sustainable solutions. The coming years will be a critical test for GM as they continue refining their compressed air engines. If they can scale production, it could mark the beginning of a new automotive era, one in which cars are powered not by gasoline or electricity, but by the air we breathe. This is more than just GM staking its claim in the green vehicle market. It's about reimagining what a car could be. Compressed air engines could represent the future of transportation, clean, affordable, and simple, offering a stark contrast to the complex and resource-intensive vehicles we use today.